an IP address is, just type into the chat. And if not, I'll just scroll to the IP section. And if anyone remembers what the IP address is about, you can just type into the chat. Maybe Hui Ning can class part. Right. So let's just get started on the recap. So last week we went through the Internet Protocol, which is essentially the protocol that lets us find devices on the network. So an IP address comes in this little format, 172.168.254.1. And IPv6 comes in this really long format. And essentially, these two addresses helps us find devices on a network. So assuming we have a network of multiple devices, we can find devices on a network using IP addresses. This means that IP addresses are unique in the sense that every device in the network has a unique IP address, because if you have two devices with the same IP address, then it doesn't really make sense, because you have people going to the same place or people going to different places given the same address. And we also went through a little bit of Nmap. So what Nmap does is that it looks for devices given an IP address, because we talked about one computer running multiple apps. So if we have an IP address, we can use Nmap to essentially figure out which ports or which numbers are available for us to check. And if we check them, we can figure out some things. For example, what kind of services are running, and what kind of OS is running on this device. So if you use Nmap on yourself, you should figure out that you're an Apple device. And we also provided some extra try-hack-me resources. And if anyone has any feedback about this workshop, you're still available to put in the details for the feedback. And of course, last week we said that this week we'll be doing the OSI model, DNS, and also packet sniffing. So for all the participants today, what I would like you guys to do is just get Wireshark and get DIG. And I think I'll just leave this up on the side for the time being while we go through the Q&A. So as per usual, the Q&A is posted on Padlet, but you can feel free to just put your questions onto the chat itself, and we'll get to the chat as soon as possible. And just to give an explanation for what Wireshark and DIG is, Wireshark is just what we call a network protocol analyzer. And it's a fancy term, but essentially it just means that we can look at the data that we're sending from a computer and basically spy on people, look into the data and figure out what's going on. And DIG is just a DNS lookup utility. And don't worry about what a DNS is, because the DNS we'll be covering further down in the slides. So as I said, for this week we'll be doing the OSI model, Open Systems Interconnection model, packet sniffing, what the DNS or the domain name system is, and DNS enumeration, which is a form of attack that targets vulnerable DNS servers. And as per usual, I have to warn you guys that everything we do here is for the sake of education, and please don't be unethical. And if you are unethical, please don't say you learned it from this workshop, because that gets us in trouble and nobody wants that. All right, so I hope all of you have gotten to the slides, and if not, let me just make it simpler. I'll leave the link to the slides on the chat. So if you guys want to get to the slides, just visit the tiny URL, and I'm going to put this in the presentation mode. So the OSI, or the Open Systems Interconnection model. Essentially, the reason why we have OSI is because we have many protocols. The internet is made up of multiple devices, in fact, many devices, and there are many moving parts. So the only way we can make sure that everything works together is by having a protocol. And I've used the word protocol a lot, but essentially a protocol is just a agreement between two things, or a contract, or I guess a standardized way of doing things. So for example, in English, we always normally we initiate conversations with hey or hello or some form of initiation, right? And you don't start talking until the other person turns around and tells you, oh, yeah, what's up? Because if you start talking and they aren't listening, they just won't hear you. And the same thing with the protocol. Essentially, when we want to talk to other devices, we have a set of protocols or standards that lets us know how we should talk to the other person or how we should talk to the other computer. So if in summary, a protocol is just a set of rules. And yeah. But the issue is because the internet is so big and so many things are on the internet, we have a lot of protocols. We have all these things and it's a mess. So to make sense of all the different protocols, we created very smart engineers and computer scientists came up with the OSI model, which basically lets us group the protocols into multiple layers. So it gives you a pretty abstract view of how data goes from your Microsoft Teams application to your computer's network interface, across the internet, to my computer, and hopefully if you pass part, I'll also hear your voice or I'll see your chat. No pressure, by the way. So we have 7 layers on the OSI model, which is generally the application, presentation session, blah, blah. But don't worry too much about all the different details. What we're going to focus on is just the network and the transport layer. So the network layer is what we did last week, the IP protocol, so the internet protocol, which essentially lets us find devices on the network, in this case, the internet. And the transport protocol we'll be covering today. And before we move on, we would like to mention that for data sent across the network, we can't just send an entire 4 GB file through the internet. What happens is that we normally have to break things into packets. So we have to take data and we cut it up into tiny bits, and then we send it across the internet. Because, oh, Kenneth is here. Because we can't actually send an entire stream. And by segmenting data into packets, we can more reliably track what's going on with the data and also keep a better trace for all the data. So in this case, I had an example of breaking up this message into 2 packets, coming from this device and going to this device. And packets normally contain multiple header fields or extra information such as the source destination and the size and also the type of protocols that it's using. As you can imagine, if you don't know the protocol we're using, it's kind of useless, right? And the idea of packet sniffing essentially is just to listen and try to find these packets and intercept them in a way that that lets us monitor the activity on the device. So we have a quick hands-on, and this requires Wireshark. And I hope for the newcomers, you guys already installed Wireshark, but if not, then you can just follow along and just look at my screen, I guess. Find the local interfaces, yeah. So let me see if I can zoom this in. I guess not, never mind. So to begin, we have to figure out which network interface we have. So I have a LAN port here and I have a Wi-Fi card here. I'm just going to use my LAN card because that's what I normally use. And you'll see a lot of data coming in because I'm currently on a call. So all these bits of data essentially is just what Microsoft Teams is sending. There you go. Let me just zoom in for you guys. So you can see a lot of text and a lot of data coming through. And yeah, there's really a lot of stuff. And the issue is you can't really see much because it's streaming. But if you stop the capture with this red button on top, what happens is it'll stop listening for data, and you can start looking at the data itself. So the time is just a number. The number is just the number packet essentially. So there's a lot of things going on here, and the first step is just to select one and figure out what's going on. So you notice there are a lot of things here. There's the internet protocol. There's something called a user datagram protocol, which we haven't gone through yet. And there's also the data. So this is one packet and it's one unit of data across the internet. And this is just a video stream, so I'm assuming this is a video stream. So if you look at this, there are multiple fields here, and here. The internet protocol will tell us what the source and destination IP address is. And remember last week we talked about internal and external networks, or private and public networks. Essentially, this is my private address, and with this address, you can't really do much. But the router in my living room will essentially take this address, convert it to a public address, and then it will send it to the internet, and that's how I connect to you guys. So if you look at this, there's multiple fields. There's a total length, there's flags, there's the protocol, which tells you what protocol it's using. And that's what I mean by a packet having a lot of data. So the actual data is actually all the way down here. And it's just a bunch of text, because this is how they represent the data that's coming through the video, but they represent it as text. Now, for the lab itself, if you guys see the presentation, the task is to go to techpanda.org and log into the website using these credentials. It's a fake test website for you to try out, but essentially we're going to demonstrate a little bit of why packet sniffing can be useful, and also why packet sniffing creates a vulnerability sometimes. So all these things, don't worry too much about it. Just copy this, and let's create a capture. So just click the blue icon again to restart. I'm going to start running a capture. And now on our browser, let's go to wrong one. What was the link? Techpanda.org. Techpanda.org. If you come here, the password was admin@google.com, and the password is password2010. Now, if you submit this, you just logged in. Don't worry about that, and we'll stop the capture. Somewhere along the line, we sent data from our device to the server with our credentials. I'll just close that. And now if you look at Wireshark, we'll fill in the details again. Yes, so hi, for this one, you can only monitor data coming through your device. Let's see. So there you go. There's one. If you type in this little thing, HTTP. Okay, so Hi has a question about how do we monitor data from other devices, and the way we do that is we have to intercept the data in some form. So the reason why Wireshark works on our device is because the data is coming from our device. So if you look at my hands, if this is our computer, this is Wireshark, and it's basically wrapping around our computer. So any data going through a computer essentially gets captured by Wireshark. But let's say you want to capture all the data on in a public network, let's say in Starbucks. What you have to do is to trick people into to go through your device such that when they send data, you can actually look at the data coming through and monitor the data. So you have to be in the middle somewhere, and that's why it's a pretty common tactic to create fake hotspots where people connect to your hotspot for free Wi-Fi, but in actuality you're spying on them. But don't worry too much about that, because we actually have this post request. So if you guys don't know what a post request is, don't worry too much about it. It's just one of the HTTP protocol methods, and it's just one of those internet protocols. But don't worry too much about it. You just type it in and just copy it for now. And if you look at this, there's an HTML form. And what's that? That's the username and password. Essentially, the form data that we sent was completely exposed, because what we did was we used techpanda.org. You realize TechPanda is not secure. So what happens is when we send data through, our data is in plain text. It's publicly available. Yeah, if you create your own hotspot and if you create your own hotspot and you have people routing the data through you, Wireshark can essentially look at the data. But you have to configure it properly, of course. And this is another way you can do it, but essentially, if you look at it, let me just look at it the other way. So if you do this and you look at the thing, you can follow the TCP stream. If you're using the same network, again, it really depends on whether the data is going through your device. So let's say my family is using the internet on their devices. The thing is, the data is going through their computer to the router into the internet, right? So nowhere in this chain of devices am I actually a part of. Like the internet goes to the router, it goes to them. So my Wireshark can't actually listen to that because the data isn't physically going through my device. And I guess the key thing is that it has to flow through your device. So if it's why isn't my Wireshark loading anything? Okay, so let me just go back. Okay, let me just finish this real quick. So if you look at this, right, whenever I click on one of these sections, like this red section, blue section, these are all the different packets. So you notice Wireshark on the right is actually telling you, oh, this is this packet, it changed. This is this packet, that's the different one. And this is what I mean by data has to be broken up into packets. So this piece of data is from one packet, but then it got broken up here, and then got broken up here, and got broken up here, and got broken up here, but it's one stream or one line of data. And someone asked, why isn't my Wireshark showing anything? Well, firstly, you need to actually record something. So let me just close that, quit that saving. Wireshark. So when you first launch Wireshark, you should be presented at this page, right? Whoever asked the question, just type into the chat if you need any more clarification. But to start Wireshark, you have to actually use one of the network interfaces. So I talked about how data has to flow through your device. And in a sense, think about your device's Wi-Fi card and your device's USB LAN as a hole in the river. So the data is flowing through your device, and Wireshark has to listen to one of these things. So I can click on my LAN, which is a local area network. It's a plugin, like an Ethernet cable. And when I plug it in, it's telling me that this data is coming through. So for some of you who are here previously, before you guys joined, I mentioned that data is streaming nonstop because I'm currently streaming video. So all this data coming through is just my video data. But that's just a quick Wireshark demonstration. If you guys want to practice more about Wireshark, you can always visit Curiosity. And I think my computer science classmates will appreciate this thing, Curiosity Labs. Essentially, these are all practices for how to use Wireshark. And it's one of our courses this semester. If you're interested, transfer to CS. Just no pressure, by the way. Just a bit of. So back to the lesson. If you guys have any questions about the hands-on or the presentation, just put onto the Padlet, and we'll get to it as soon as we can. Is this Wireshark packet sniffing active or passive? So it really depends on where you put Wireshark, because when we talk about active or passive recon, it's about the level of involvement and the level of detectability we have with the target. So Wireshark can't really be a passive reconnaissance thing, because Wireshark has to be installed somewhere along their chain. So from the device to the internet, from the internet back to the device, the only way Wireshark can listen to the packets is if we were somewhere in the middle. So if we, let's say, put ourselves in the middle by installing malware, then that becomes an active scanning reconnaissance. And other than login infos, what other info do you usually look out for? It really depends, because this what Wireshark does is that it gives you the entirety of the network data. So it really depends on what you're looking for, because I'm not too sure what else you can find, but normally that's where interesting things pop up. For example, with some, let me think. With some CTFs, what they'll do is they provide you with a PCAP or a packet capture, or all the data essentially compressed into one file, and they'll ask you to open it and basically go through that file to look for any sort of details. And you'll be able to find any sort of details that go through the network. So if they, let's say, send some login info through the network, or if they send a secret flag to the network, or if they have some secret data going through the network, then essentially you can see the data in the Wireshark. Of course, Wireshark exposes all the different ports and all the different IP addresses as well, but for that we have other methods. We have other methods to figure that out. So just a quick summary. The reason why we could see the passwords in admin username is because we have HTTP versus HTTPS. And HTTPS is basically hypertext transfer protocol, secure. And secure just means that they encrypt it, and when they encrypt it, the data becomes unintelligible to you. And we'll talk about encryption in, I think, week 7. Week 7, yeah. So if you're interested in encryption and how to break some encryption, join us in week 7 in 2 weeks' time. Wait, no, week 8, 9, week 9. Sorry about that. Week 9. Yeah. So moving on, we'll talk about a little bit about TCP IP model. It's not too important, but I'll just run through it quickly. Essentially, the TCP IP model is just implementation of the OSI model. Again, don't worry too much about it. The idea is just that we are learning these protocols to find vulnerabilities in these protocols. And the first transport protocol we learned is called the TCP. Sorry. Let me just start again. So the transport protocols essentially guarantees us stuff about how we send data across the network. So I mentioned that the network protocol like IP helps us find devices on the network. But a transport layer protocol essentially helps us guarantee a few things about how we send the data. For example, we have the TCP protocol. Essentially, TCP guarantees a few things like a reliable connection, and no packets will be lost, or no packets we have the packets available in an in-order stream. And of course, we also have a few extra features like flow control and congestion control, but that's extra information. You don't have to worry about that. But the key feature of TCP is that it makes sure packets are always in order. Because in a network, you can have high delay, you can have like packet drops, or like networks unreliable. So what TCP does is that it makes sure that data sent across the network will always be in order and in the right stream. And this is just a few basics about what TCP does. But again, I don't think we have time to cover this. So if you're interested, you can always go through this by yourself. But don't worry too much about it because we won't be covering, or we won't be using this too much in our workshops or this week's content. There's some drawbacks. Establishing a connection is slow. But the one reason why we use TCP is because TCP guarantees that we get all the data. So when we're loading web pages or when we're reading emails, we can't afford to lose like 1A or 1B somewhere along the line, because if we do that, then our web pages are incomplete or our emails are wrong. So TCP is used in the cases where we need reliable and in-order data. On the other hand, we also have the UDP, or the user datagram protocol. And user datagram is normally used for stuff where we don't really care if we lose data, because we can make up for it or we can guess what's missing. Unreliable datagram protocol, yeah. So UDP doesn't set up a connection. Instead, it just sends data as fast as it can, and it's a best effort service essentially. It tries its best, but it won't guarantee that you'll get the data. So definitely don't do bank transactions or payments across UDP, because there's a possibility that the packet will get lost and the other person won't even know about it. But in this case, when we're live video streaming, we don't really care, because let's say I send you an UDP packet and you lose it. All that happens is that you have a few drop frames, but eventually you catch up because you get more data, you get more UDP datagrams, which will just sync up your video and you'll be back to normal. So we don't really care about reliability with UDP. So we just use, we don't really care about reliability with video streaming, so we just use UDP. Same with online gaming, because online gaming we can't really rely on a TCP connection to always set up a connection, because that'll be really slow, right? So what we do is we just use UDP and we can just guess the data that's missing. And it's a quick little joke, but TCP is essentially about, it's like asking a friend for a toy. Your friend confirms that you want the toy, and you say, yes, I want the toy. And they'll give it to you really, really carefully. But UDP is more like, oh, here you go. And you don't really care about it anymore. It's just throw it away. And yeah, that's just a quick little analogy. So the summary is just TCP has a three-way handshake to set up the connection before it sends data, whereas UDP just sends data straight away. And we had a little section last week about what a connect scan and a SYN scan is. Essentially, a connect scan ensures that our TCP connection is fully established, whereas a SYN scan just sends the first packet or the SYN, and after that it just stops. And that's why it's called a SYN scan versus a connect scan. All right, so now moving on to new content for this week, we have what we call the domain name system. Because last week we talked about IP addresses, right? About how Google can run on YouTube on their computers, but we don't know where YouTube is, so we use the IP address. But nobody actually remembers like all the numbers, like 111.12.45, because we just use youtube.com. So what domain name systems do essentially is to provide us with a way of converting our URLs into IP addresses and to convert it from IP addresses back to URLs. In a sense, DNS translates the IPs with the domain names and vice versa. And the domain name structure essentially is built like a tree of different domains. So when you look at www.google.com, the very first thing you should look at is the very right side. So read it from right to left. So com is the global company domain name, but it's the standard. It's the most popular and most reliable. Not reliable. It's the most well-known domain name top-level domain. So we have things like google.com, youtube.com, facebook.com. But below the com, we also have the different second-level domains. So stuff like Facebook or Google, they have their own name, right? So we have google.com and etc. etc. But of course, beyond that, we also have third-level domains. For example, with Google Maps, it's maps.google.com. So if you read it from right to left, it's the first com, and then you go to Google, and then you go to Maps. And if you think about how this is laid out, it's essentially getting more and more specific. So we didn't list it here, but we also have country-specific top-level domains like .sg. So .sg is the top-level domain that controls .com.sg, .net.sg, and .gov.sg, and all other things below .sg. But essentially, a Singaporean authority will be controlling this domain name, and everything below it will fall under this Singaporean authority's control. And every one of these dot somethings acts like a DNS zone. So a zone is just one portion of the entire DNS namespace. So every single URL you can find on the internet, it's separated into different zones. And a zone doesn't have to include just one domain name, because a zone can be managed by one person having multiple domain names. So let's say example.com has cluster, has mail, has www. Everything can be put under one zone so that one administrator will manage all these different URLs under this domain zone. Have I lost anyone so far? Because I understand I'm going a bit fast, and if I need any, if you guys need any sort of time to absorb that, just let me know, because I wouldn't want to move on without everyone being on the same page. And again, can you go to the Padlet to get any feedback? If not, then I'll move on to what a DNS server is. Essentially, a DNS server is a computer that provides us with all the different names and the IP addresses. In this case, we have an example where Chrome asks, oh, where is example.com? And the DNS server will tell you, oh, example.com is on 12.34.56.78. And your computer will be like, oh, thanks, I'll go to 12.34.56.78. And when you go there, the web server was, oh, here you go, I found example.com, and it'll give you back the content. To summarize, DNS essentially gives you a way of converting your URLs into IP addresses. And your IP addresses help you find the actual computer to go to. So how the system works is that it has a table of records, or in this case, it's just a bunch of text essentially. But records basically tell us how to convert a URL to an IP address. For example, we have the A record, or what we call the address record. And the address records is most simple record where we say, oh, if we get google.com, we'll convert it to this IP address. For everyone who's downloaded Dig, if you run these commands, this should be what you get. So dig works by asking for the URL you're looking to convert, and then the type of record you want. So in this case, we have an A record. So A record will basically be from the name straight to an IP address. And if you have a quadruple A record, it's just the IPv6 version. So if you use A, you will get a bunch of IPv6 addresses. This long semicolon thing. Everyone clear so far? So A records converts directly from your name to your IP address, and from your IP address back to your name. The more interesting thing is called the CNAME record. So the canonical name, CNAME, basically lets you redirect one IP address, one domain name to another domain name. And this is really useful if your site is, let's say, upgrading from one subdomain to another subdomain. For example, with Reddit, they have a old website called old.reddit.com, but this website is hosted on this Fastly content provider. So when you look to old.reddit.com, it will forward this. It'll take this address, and it'll perform the DNS lookup again using this address, record. So you type in old.reddit.com, it'll convert it to reddit.map.fastly.net, and then it'll take reddit.map.fastly.net and then convert it to this address. So CNAME just redirects a domain name to another domain name, and it's useful for redirecting domains to other domains. And the thing I find confusing myself is the name server record. So name server record, what we mentioned, is basically telling the service where the DNS server is that contains the actual records for this URL. If you go back to this, when we ask google.com, a server somewhere gave us this URL. So this server over here, we don't know where it is, because what we did essentially was we asked google.com, and some server somewhere gave us this address. But when we use the NS record, or when we ask for the NS record, we're asking for where's the actual server that is giving me these addresses. So if I search google.com with an NS record, it'll tell me that, oh, these records are stored on ns3.google.com. So ultimately, ns3.google.com or ns4, ns1, ns2 is the actual computer that contains all these records that tells people where Google servers are. And this is where we will be attacking most of the time, because this is where all the records are stored. And lastly, we have text records. So text records contain text information. And it's especially useful when we want to store any arbitrary text in our DNS service. For example, Google uses text records to store the credentials and any sort of cookies they might need. If you can see over here, there's like all these bunch of texts, but it doesn't worry too much about it. With some CTFs, however, they actually provide you with challenges where you have to search up text records. So we have a hands-on for you guys here. And we've created a website where you can basically try to use Dig to find a flag. In this case, it's a free text record. So if anyone, I'll leave you guys about 5 minutes to just try this out and just go through this hands-on. And if you can find a flag, props to you. But if you have the slides, it should be quite simple, because it's exactly the same command, just change the URL. And I hope that gives you a kind of understanding for how DNS records actually work. Okay, so just for everyone, just take like a 5-minute break to get some water, go for toilet break, or just try out the hands-on if you like. Of course, this hands-on will always be available for as long as I'm alive, so don't worry too much about it. If you can't try it now, or if you have some issues downloading Big, just put it into the Padlet, and we'll help you out and try to help you debug this. And in the future, you can always try it out again, and you should get flagged. And maybe one day we'll have we'll create a platform for you to just submit the flags and get some points, and you can have a leaderboard and stuff like that. So, does anyone have any questions so far? Right up. Or perhaps Denzel, any questions? Okay, so while you guys are doing the Nmap, I'll just try to answer a few questions on the Padlet. So we have a question about how do we know whether we are on TCP or UDP? So I think fundamentally, you're not really on TCP or UDP because TCP or UDP is just a protocol. TCP or UDP is just a protocol that defines how data is transferred to an application. So you can't really know whether you are on TCP or UDP, but you can figure out if an application you're using is using TCP or UDP. And in that case, normally you know based on the type of protocols that you're using. For example, the web HTTP is traditionally built on top of TCP. So if you're using websites HTTP, you are generally using TCP with some exceptions. But if you have video streaming and they're using, let's say, the QUIC protocol, then you know that QUIC is built on top of UDP. So that's how you know you're using UDP. And to confirm everything, you can always use Wireshark. So Wireshark is the de facto way of confirming whether you're using TCP or UDP based on the apps you use. I hope I answered your question, but if not, I'll fill it in later because right now we should get back to the hands-on. So has anyone figured out the flag yet, or does everyone have issues downloading DIG? Mac users should have no issue doing this because Mac users should have DIG pre-installed. But for Windows users, I'm so sorry, I really don't know how DIG works with Windows. Anyone? Just put an answer into the chat. It's all right. It should be in the format of CHF with curly braces. Yeah, Jessica, nice. Yeah, so CHF, that's it essentially. So I hope that was a little bit of fun, because essentially what happened is that I added a flag, or I added this flag to my domain name service. So it's stored somewhere on my on a domain name server. And because you guys use DIG to look for text records, the server will return text records and you get the flag that I put in. Yeah, Jessica got it right. So the reason why we're trying to learn DNS is because DNS enumeration can be, sorry, the reason why we're learning DNS is because if we know the DNS and if we attack a DNS, we can kind of review a lot of information about the organization. So we can retrieve usernames, hidden IP addresses, or even like different computer names and sensitive data that's stored in the text records. And to do that, we use DNS enumeration. Big slides. DNS enumeration is just the process of locating DNS servers. And we use DIG just now to figure out a flag from my website. But if you use DIG, you can also find the name server. So which server is holding the records that are storing these flags. And we can also do a more critical vulnerability called a zone transfer attack. So I mentioned before that DNS zones are basically just partitions of the DNS global space that's managed by one entity. So these zones, when they're managed by one entity can normally be used to, so we can normally use a zone transfer to copy all the data from one zone into another zone, because we want, let's say you want to copy yeah, we use NSLookup. Oh, NSLookup is built with Windows. Thanks, Vaita. I did not know that. So yeah, let me just. Windows users can use NSLookup, and Mac users can use NSLookup as well because it's built in. I just thought DNS is simpler, but we can go with this then. All right, thank you, Vaita. I did not know that NSLookup was available. But these two tools do essentially the same thing. Yeah, thanks, Vaita. All right, so I'll replace everything with NSLookup if there's any issues. All right, back to this. So again, a zone transfer is essentially copying records from one DNS server onto another DNS server. And if the administrator of this DNS server misconfigures their service, then we can actually exploit this vulnerability to copy all the records from this DNS server onto our own machine. And this is a lot more vulnerable because it exposes all the subdomains. Like for example, if Google has like hidden secrets, like maybe they have secret.google.com, but just hidden somewhere, we can expose all these things by using a zone transfer attack. Of course, it's a very rare bug because it's pretty well understood and it's pretty secure now. But it's definitely a really interesting thing to learn and try out. And to do a zone transfer, we have to use the AXFR protocol. Don't worry about what it means. Don't worry about its name. Essentially, we just want to use AXFR when we look up for DNS records. So of course, an AXFR request will only work for vulnerable name servers. So if you try to use a AXFR protocol on a properly configured NS name server, it will just fail and you won't get anything. But the kind people of the internet have created a website called zonetransfer.me, which basically gives you a misconfigured DNS server. So the first step in transferring a zone is to actually find the name server and then try to transfer the zone from that name server. So if you guys have NSLookup or DIG installed, then I would like you guys to try to do this without any sort of hints. And of course, if you have any questions, like really any questions at all, just put it into the chat or put it into the Padlet. Let me see what my next slide is. And just don't look at the next slide if you're trying to do this for real so that you don't get the answer so fast. You can close Wireshark. By the way, we'll be using Wireshark for next week a lot more because we'll be doing something called forensics, which is the idea of going through data to find more information. So forensics is an interesting field, and we'll be done with most of the networking stuff. And if you guys are confused about networking, then look forward to the next lesson for less networking stuff. And of course, please put into the Padlet if you have any questions about what's going on and what's any confusions you have about the network. And we'll be more than glad to help you guys with any sort of the issues with a networking understanding. Okay. Let me just, I think NSLookup is a, okay. I think for NSLookup, let's just all use NSLookup for now. I think that'd be nicer for the Windows users as well. So again, that was just an artificial example because I put a flag in myself. But normally, text records are used to store any sort of configuration details. For example, if you look at Google, let me just change this to text. Wait. You know what? I don't know how to use it. But here's the thing where you should use Google. Let's look up how to set Oh, not bad. Hello. So let's say we're looking for a text record on google.com. You look at this, you see that it exposes some credentials like DocuSign, their global signature, some Facebook verification token here, and it also has some metadata over here. So these records are stored on the name server itself because it's to configure the name server. And in some cases, some services might actually configure this wrongly, and you might expose some critical information about the service you're using. So again, DNS enumeration is a scanning process. So you're looking for any information about your target, right? So when you search for text, essentially, you can find extra information about your target and I guess craft your attack more deliberately. In the example I gave, the hands-on I gave, it was just an artificial. It's an artificial example to give you a sense for how a text record CTF can be set up. It's a really simple challenge, but ultimately it's just to give you the concept for how text records work. And I hope that answers the question about why that thing was there. It's just a little fun thing, don't worry about it. But back to the lesson. Right, so I mentioned a name server is just a server that actually holds the DNS records, right? So we want to find these servers such that we can actually attack it. So the first thing is, let's go, I think we want to find the type. By the way, to get to here, you just type ns lookup with nothing and just type enter, and you get into this this command. This get a caret or the arrow sign. But from here, we just set the type to we want name server, so name server is ns. Over here, name server records. So we want to find the name server that actually contains the actual DNS records. And now we want to attack zone transfer.me. Okay. So if you look at this, we'll be exposed to NSZTM1 and NSZTM2.digi.ninja. So these are the actual servers that contain the actual DNS records of this website. So of course, if you look at A records, NSZTM1.digi.ninja, you notice it'll give you an address. So this is the address of this server, but don't worry too much about it because, sorry, this is essentially telling us that to get to this server, use this IP address. But we don't need that because now our goal is to transfer the zone. So to transfer the zone, again, we say we use the AXFR protocol. AXFR, yeah, AXFR. And now with the types of the AXFR, wait, I forgot the, I forgot the what. You go to NSCTM1 dot, was it digi dot ninja. I'm gonna zoom out a bit because I think it's gonna be a lot of stuff, but I hope everyone got to this stage. If not, then let's take some time to process what this is. Essentially, we're saying I'm gonna make an AXFR request to NSZTM1.digi.ninja. And how we found NSZTM1.digi.ninja is by looking for the name server record from the zonetransfer.me website. All right, I'm gonna hit enter and failed. Hold up. Huh. Troubleshooting. All right, maybe that failed because okay, so I guess NSZTM1 doesn't work, but maybe NSZTM2 will work. And we just gotta try and error, right? Goes AXFR. And this should work, please, come on. NSZTM2. Huh, that's interesting. There's no history. Oh, I'm silly. Okay. Let me explain the syntax a bit more. I made a mistake. I guess we all do. So with dig, I made a mistake in trying to dig this actual server. But what we should be asking for is that we want to use the server to zone transfer. So with dig, the syntax is use the @ sign or the symbol of the two key. So dig at this server, zone transfer.me, and use AXFR. And this should work, but for the benefit of our NS lookup people, let's try this again. Set type equals to AXFR. And let me figure out the syntax for NS lookup. How to set NS server. Let me see. NS lookup guide. Yeah, there's a guide there, but of course. Oh. Set. I think it's set. Mostly NSZTM. I'm sorry about that. Never mind. I will get back to you on the NS lookup syntax, but there you go. Issues. So what we've done essentially is we've transferred all the data from this name server for this address, and we've copied all the data into our machine. So we have zone transfer me. That's pretty normal. Again, it tells us some information about the server, Windows XP, its verification code. MX is a mail server. Don't worry too much about that. So these are all the different mail servers it uses. The name server it uses, and Acme challenge. You have some text. You have some text tokens over here. You have multiple records here, and you have this. And there you go. Yes, your first I guess leak is that under contact you have remember to call blah 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 blah. And I hope some of you can understand why this is an issue, because one, we've exposed their email and we've exposed the number. Of course, this is fake, but the idea is that using a zone transfer, we've exposed some data we can use to, let's say, do a phishing attack where we social engineer some people, or we can make ourselves look more credible by having this information really on hand, right? We also have deadbeef. We have that's how they use the zone transfer with the G.Ninja. And what else do they have? It's multiple text. There's a lot of text, but there's a cross-site scripting there. But there you go. So that's how you do a zone transfer. And I hope you guys found that a little bit interesting. I understand it's not as visual as the webcam we had in the first week, but of course, most things won't be that visual. This is the link that Whiteout gave, by the way. So how we use this is how we use NS lookup. And I like to set the record straight that for all of us, for everyone, especially for me at least, a lot of my knowledge comes from Google and searching things, and I guess learning through trial and error. So if you feel like you're lost or if you feel like you're not catching up, really don't worry about it, because you have the entire internet at your fingertips and you have the entire internet as a resource. And you can take as much time as you need to figure out all these things, because these resources will never go away. And if you fail, you can always just keep trying again and again. So at least for me, you noticed me like struggling there because I had no idea how to use it. So I started searching Google for it. And that will be a very common experience you have in a lot of tech. And our goal with this workshop is just to give you the fundamentals. But of course, the fundamentals can only carry you so far, because ultimately you have to get into more technical and more. You have to get into more technical things to learn like the bleeding edge and the I guess the more modern approaches. But we hope that with these beginner workshops, it will spark your interest in cybersecurity and all these different vulnerabilities and hacking in general and CTFs, such that you can actually go out into the field on your own and have a fun experience learning cybersecurity. So I had the answer right here, and I forgot this. I just wrote this like an hour ago, so that's surprising, but yeah. So I explained the reasons why we did the syntax, and I'll add a slide for NS lookup specifically about what you should use, but you shouldn't need the slides to use NS lookup, because like I said, there's multiple resources online on how to use NS lookup. There's always Google, and you can always search it up. And I hope you guys had a fun lesson with the DNS. For more resources, of course, there are online tools to do DNS zone transfers. There's a recon tool that lets you automate a lot of these processes. And there's also the Zone Transfer Me, which is a website that explains why he set up the website in the first place. And there's also a thing called subdomain enumeration, because we've run out of time, but the idea of subdomain enumeration is just that we try out every single possible subdomain. So we start a.google.com, b.google.com, c.d.e.f, and we go all the way to z, and then go to aa.ab.ac, etc., etc. So that's just subdomain enumeration. And we have tools for that as well. So you can take a look at that if you like to, because those are fun. And again, if you have any issues with installing tools or like installing programs on your Windows or Mac device, just put it onto the Padlet. I think these kind of questions will be a bit harder for us to solve during the lesson itself. So we'll get back to you as soon as possible on the Padlet. Where did the question about the TCP and UDP go? No worries, I'll just transfer the chat onto the Padlet whenever I have time. And next week, we'll be doing a bit more forensics. So I mentioned forensics is just the idea of looking into data to find more information. So it could be, for example, what we did just now with Wireshark, look into the network data to find text, to find the passwords and usernames. Or we could look into an image and figure out how they hide data from the image. And I think if you guys were here for the first workshop, you'll notice the EXIF tool, EXIF-TOOL. That was essentially a forensics tool that can be used to find metadata of images, because EXIF is a metadata format. So it's just to figure out metadata from images. But the other things that are really interesting, like steganography, and you guys will have a lot of fun with that. So if you're interested, please come back next week. And of course, back to the Padlet. If you have any questions, just go to the Padlet, sign in with the password, and yeah, just ask us any questions about the workshop, about the content, and we'll get back to you. And that's all for this lesson. I hope you guys had fun with this. I understand it's a bit faster than you would probably like it to be, but thanks again, Jessica, for finding the flag and sharing. Thanks, Whitetuck, for saving my butt over there and helping me out with the troubleshooting. And Zahai, Minghao, Yihao, thanks for sharing this. Later oh yeah, I think it was shared on the Telegram group. So Let's go to the WebPads Telegram group. So Flare is another challenge you can try out. And I saw someone contribute the answer for using host. So some background about Waitak. So Waitak is very interested in, I guess, binaries and reverse engineering. So I think he's very enthusiastic about sharing reversing challenges. So reversing it's a little bit of forensics as well, but essentially you're taking a program that's been compiled, like a fully functional program, and you try to work out how this program works. So you try to reverse engineer this program to figure out what's going on underneath. Yeah. Cool. Do I have host? Let's see. Do I have host? All right. So Yihao had a pretty great contribution there. Host of type AXFR. And thanks for the contribution. There you go. Same thing. Yeah. So like this, I guess I should have used host or NS lookup, right? Because I think big is a bit more specialized. All right. So thank you for joining us for the workshop, and I hope you guys had a good night. And thanks for spending thanks for spending your Thursday evening with us. And I hope you learned something. All right. Enjoy your Thursday night and prepare for Friday, I guess. All right. Thanks for the talk. And right. You guys have fun. All right. Thanks again, Jessica, for the sharing. All right. Have a good night.